Every statement or proposition is only between true or false. With the use of the concept of truth values, we can divide compound statements into two distinct categories. So we can identify whether it is true or false. An easy way to understand a statement is to make our own truth table. There are 5 types of compound propositions. First is the negation. Second, conjunction. Third is the disjunction. Fourth is the implication. And fifth is the biconditional.
First, we're going to analyze negation. This is the symbol of negation. This means the opposite of the statement. Propositions are commonly derived by P, the hypothesis, and Q, the conclusion. In creating the truth table, let's put P and the negation of P. Here, let's put true, and the negation of true is false. Here, let's put false, and the negation of false is true. For example, this statement, 31 is an even number, is false. But if you put the negation of the statement, 31 is not an even number, this makes the statement true, or the negation of our hypothesis.
The next type of compound proposition is the disjunction. The truth value of P, Q depends on P or Q. This means that disjunction of two propositions, in this case, P and Q can only be false if both proposition is false. Let's put P and Q and the disjunction of P and Q in the table. If both statement is true, then the disjunction is also true. If the first statement is true and the second statement is false, and vice versa, the disjunction will be true. And if both statements are false, then the disjunction is false. Let's have an example. In this example, 2 is odd is false, or 2 is even is true. Then going back to the table, if one statement is true, then the disjunction of the proposition is true. The statement can only be false if both proposition is false.
The next type of compound proposition is conjunction. It is similar to disjunction, but instead of if one proposition is true, then it is true. In conjunction, the statement is only true if both statements are true. If one statement is true and the second statement is true, it will be true. If one statement is false and the second statement is true, those will be considered as false. Likewise, it will still be false. And if all statements are false, it will still be false. For example, 4 is even and 16 is a perfect square. As you can see, 4 is even is true, and 16 is a perfect square is also true. Looking to the graph, if both statements are true, it will also be true. If one, example, 4 is odd and 4 is a perfect square, if 4 is odd, is considered false, and the second statement, 4 is a perfect square, is true. Looking back to the graph, if one statement is false, it will always become false. As you can see here in the truth table, the only true if both statements are true.
The next proposition we are going to discuss is simplification. Imagine you have a friend that will take his exam. He said that if he passes his exams, he will then treat you to lunch. Now, the hypothesis in our statement is if he passed the exam, and the conclusion in our statement is then he will treat you to lunch. You're the one who is going to be treated, right? That's why the only case that it is only unfair for you is if he passes the exam and he does not treat you. That is an example of a true hypothesis followed by a false conclusion. To visualize, let's put P, Q, and P implies to Q. Let's put true here and true in the conclusion. Let's put true in the hypothesis and false in the conclusion. Here, let's put false in the hypothesis and true in the conclusion. And let's put false in both of the statements. In the first case, both statements are true, which makes it fair for you because he will treat you to lunch because he passed the exam. In the second case, the first statement is true and the second is false. He passed the exam but didn't treat you lunch. This case is unfair for you because he already passed the exam and he does not treat you. So this is false. The third case is he does not pass the exam but he do treat you. So this is still fair for you because you are the one who is going to be treated. On the fourth case, the first statement is false and the second is still false. This is fair for the both of you because he didn't pass the exam. So why treat you, right? So this statement is still true. So in implication, the only case that is going to be false is when true implies to false.
And the last type is biconditional. The statement is true if both propositions have the same truth values or they are the same. So let's put this P, Q in the biconditional of P and Q. So in this first case, if P, Q are true and the biconditional of this is true, both propositionals have a same true, so the statement is true. In the second case, if it's the first one is false and this is true, so the biconditional of this is false. If the one proposition is true, then the statement is false. Then the third is if this is true and this is second one is false, then the biconditional of this is false. In fourth case, if this is false and this is false, then the biconditional of this is true. So for example, 30 is divisible by 2 and 15 is a multiple of 5. So if 30 divisible by 2 and 15 is a multiple of 5, if this is true and this is true, they are the same statement or propositions, so this is true. Going back in this case, if P is true and Q is true, so the biconditional of this is true. So if we change this 30 divisible by 2 by 4, so this will be false. And this 15 is multiple of 5 will remain true. In this case, going back,
if P is false and Q is true, then the biconditional of this is false. To understand easily, the statement is only true if both propositionals are the same.
Now, we are going to apply what we have learned. The conditions are: let P represent a true statement, Q a false statement, and R a false statement. So we can easily say that P is true, then Q is false, and R is also false. Now we are going to solve the given problem. The negation of R implies to P, or the negation of Q, and the negation of P and the biconditional of Q. Now we are going to substitute each of these variables into true or false. Now, the negation of R, or false, we are going to write the negation of false implies to P, which is true, or the negation of Q, which is false, and the negation of P, which is true, biconditional of F. Now we are going to simplify each of these variables. The negation of F, which means true, implies to T, or the negation of F, which is also T, and the negation of T, which is false, biconditional of false. Now, to solve this, we are first going to solve what's in the parentheses. True or true, going back to our truth tables, true or true will result into true. False, biconditional of false, they are the same variables, which makes them also true. Now, true implies to true. Going back to our truth tables, truth implies to true is true. Copy this. True and true will result to true. This is our final answer. Now, another example, but you should try to solve it first before we solve it together. Now, the negation of P, which is the negation of true, biconditional of false, biconditional of quantity true, and the negation of false. Biconditional of true implies to the negation of false. Simplifying the negations, the negation of true is false, biconditional of false, biconditional to the quantity true, and not false or true. Biconditional to true implies to the negation of false, which is also true. Next, false biconditional of false. Going back to our truth tables, false biconditional of false is equals to true because they are the same variables. Next, true and true will result to true. Biconditional of true implies to true, which is also true. Now simplifying this quantity over here. True, biconditional of true, they are both true, so we can easily say that this is true. Now bringing back true, biconditional of true, just like here, is true. So the answer to that problem is true. The next topic we are going to discuss is exploring conditional propositions. Conditional statements are called if-then statements. What we said earlier, if is the hypothesis and then is the conclusion. There are three types of conditional propositions. First is inverse, second is converse. and the third is the contrapositive. In converse, if the statement P implies to Q, the converse of this is Q implies to P. Next. In inverse, if P implies to Q, the inverse function of this is the negation of P implies the negation of Q. The final type of the conditional propositions is the contrapositive. In here, this is both converse and inverse. So, if P implies to Q, the contrapositive of this is the negation of Q implies to the negation of P. To summarize, this is a table for you to understand.